Alright, so this is where we were with our last video. So in this one, what I want to do is I want to build these, I want to build these circuit lines on her skin. So this is essentially what we want to do in this particular video. Now, when I did this one, I used a really complicated approach, which definitely wasn't a very smart idea. So I figured out a slightly, simpler way to do this. So that's what we're going to do in this lesson. So this is essentially two things, because what it is if you can spot here, like you get these nice little circles in the middle. So what I'm going to do is we're going to select like some of the top points and some of the base points and have those connect. But I'm going to make, we're going to extract like a centroid and then generate a hole in the middle. So what happens is that the lines will look like they're flowing around, this particular hole. So it looks a little more organic. So first we'll generate the basic circuit lines, and then we'll generate this, the hole in the middle. Okay, so let me just get started. Okay, so one of the things I want to do is I just want to open up like some more patches on the skin. So we'll just come to the delete and I'll say 0.3. So it sort of, deletes a little bit more. Yeah, did it delete anything more? Yeah, I think the back is a little more open. Let's just try a little more. Let's go to 0.4. It takes a few seconds to calculate. Yeah, there you go. Okay, perfect. This is not important, but you just get a little more, a little more of the skin showing, so that, you get a few more of the circuit lines. Basically that. Okay, so the first thing we're going to do is I'm going to duplicate this. So do Control-C, Control-V, and I'm going to come out here, to this side. And what we'll do is I'm going to take this delete and we'll do delete non-selected. Okay, so we have this part which is open. All right, so the first thing is I'm going to take this and we are going to, now we don't need to delete any attribute or anything like we had done with the chest armor, because we want to work with individual pieces. We don't want to work with clusters. So if I do a for each, it should just work, the way it's supposed to work. If you want to bring colors back to like individual faces, what we can try to do is let's do a wrangle, and I'll create a new, we'll just do a new wrangle, a new attribute called f at, let's say pt, and I'm going to just do a random of c, which is controlling, at c, which was storing all our point numbers. And so what that should do is if I go to a color, this is not important. I'm just doing this, just for the sake of it. So if I go to the color and I say ramp from attribute pt, I should, okay, hold on. This is a primitive attribute. Yeah, so let's just go to primitives. And this should also be primitive. There you go. See, so now we get, random coloring back for, or we can try to do random from attribute, and that's also fine. So you can just do this. Yeah, so ram from attribute is perfectly fine. Okay, so what we want to do is I want to select some top points and some base points on a per piece basis. So what we can do, which is very simple, is we can, if we generate a gradient in the y direction, because mostly this is all flowing downwards, we should be able to use that to select points. So I'm just going to come in here to the piece and we'll take an attribute warp. Okay, I'm just going to jump in and you'll get a node called relative to bounding box. So just take a relative to bounding box, take the first input, which is our geometry, and then we'll do a vector to float. Like if you directly connect this to CD, see, you'll get this. So each will automatically get its own, bounding box color, which is not what we want. So what we want to do is we just want the y-axis and we'll connect it through a ramp. Okay, so we'll just connect the y here and take that to CD. See, there you go. So you have like, individual colors happening this way. And then I can very simply just take a group expression and I'm going to select points. So let's call this top and we'll say at cd.r is greater than 0.8. So that will select all the top points. And then I'm going to do, and then here itself, we can add a second expression. We'll call it base and do the same thing. We'll do add cd.r less than 0.2. So we'll get the bottom points. And that's it. Then you take something called as a find shortest path. And what this does is, given like two input points, okay, like one for the beginning, one for the end, it will move across the mesh and try to find, how to connect those 2 points. So if I just come in here, I'll say start points is top and then bottom points is base, and there you go. Okay, so you have multiple options. You can say from any start to any end, each start to each end, and then any start to each end. So it kind of just reverses. And then you can do like each start to corresponding end, that requires the same number of points. So if it's like 5 points below, then it needs 5 points on top. So that's much more difficult. Any start to each end, each start to each end generates far too many. So we don't really want that. So we'll keep it to each start to any end. Now the problem is this doesn't look very nice. Okay, like they're very straight lines. They don't look very fancy. So the simplest way to correct this is, before we do anything else, you can take a remesh. And what a remesh does is it triangulates everything. Okay, like it gives you like a triangulated mesh and just lower, the value, and you will immediately see a difference. See, so now the flow lines are a lot better. They look much more interesting. Now, what we can also do is, I want more lines, like this is not enough. So I'm just going to duplicate this. So we'll do Control C, Control V, and I'll reverse this. Okay, so I'm just going to take this and I'll say, instead of each start to any end, I'll say any start to each end, and that will sort of reverse the whole thing. So if we merge them together, it will look a little more interesting. Like it will look a little more dense. See, so that's essentially it. Like if I do a null and bring this out, we'll just do out lines. And now what I had done with my particular file was I rendered these as curve primitives rather than giving it thickness, because I was rendering with Octane, and on a few frames Octane would crash. Like for some reason, I guess the lines would overlap or something would happen with Polywire and it would crash. But I realized if I just turned it into like curve primitives, it would render a lot faster and I wouldn't get any problems. But you can just give it a simple Polywire and that would be fine as well. Like I can just do a Polywire, keep it really thin, and we'll turn off smooth point and just drop it in the middle. So you'll just get this, like you'll get like a little bit of stuff like this. And then I'll give it a normal here, otherwise it will turn black. And if we want, we can try to give it some color. Like let's just see if this works. Okay, like I can, before the Polywire, let's do a for each. This is just for fun. Okay, I'm just going to do a wrangle here, and let me just check if I've done this before somewhere else, so I can just very easily copy paste from there. Yeah, I think I've done something called thickness, right? I just need to find it. Yeah, there we go, thickness control. So I can just take this and I can copy this. So I'll just take this part, do Control C, come here. So I'm going to do at cd is equal to 0, and we'll do at cd.r is equal to this without that. Yeah, so what we should get is, see, everything gets a color like that. So the Polywire will get some color. Or if you want to get color control, then we can just transfer the cd.r to the full color value. So if I just do at cd is equal to at cd.r, it will be grayscale. And then I can just put a color node here. and I can say ramp from attribute CD, and then you can just pick whatever colors you want. So let's say if it's supposed to be like, say, red to blue or something like that. Yeah, I think that should be okay. I'll just do outlines. We'll do object merge. Do the same thing. Yeah, so just do Control X, zoom out, and yeah, there you go. So that looks nice. So now, of course, the one thing we need to do is we need to mirror this. So we'll just come down here, come up again, and just do a mirror. Yeah, there you go. So if I try to change the frame, yeah, there you go. See, so that looks pretty nice and fancy. And we'll just do, we'll save this as chapter 8. Okay, so now the other thing we want to do with this is I want to generate a hole so that the lines will kind of, flow around the whole thing. If you want to increase the amount, we can try to reduce the edge length, which should give us more points. See, so you get like, more lines flowing, and we can try to lower the poly wire to, let's say, 0.008. So they're thinner. What you can also do is you can give it a little bit of a peak, or let's try something, right? Let's come in here. I'm going to do a peak and push it into negative. So let's try minus 0.01. Let's drop that in the middle. Yeah, so what happens, it gets pushed below, the panels. So it's not like overlapping with it. Yeah, that doesn't look too bad. Okay, so what we're going to do is, like, we have the remesh done. Now what I want to do is we're going to find the, we're going to extract the centroid again. So I'm just going to push this to one side, and we'll again do, extract centroid. Yeah, I think this is fine. Or let's try to do something else. Yeah, let's not extract a centroid. Okay, because what I want to do is I want the size to vary based on each piece. So we're going to take a sphere. Okay, so we'll get a sphere which is roughly the size of this, and yeah, turn off accurate bound, so it sort of comes in a little bit better. And then I'm going to take a transform, not a soft transform, take a transform, and we'll come to the pivot, and we'll put the pivot in the center. So we'll do like $CEX, $CEY, $CEZ. So that puts the pivot in the middle, and then we can just scale it down to, something really small, about that much. So the advantage of this is that we should technically, if I merge this, with this, you'll basically get, varying size spheres, around each thing. So which is roughly what we want. Okay, then what I want to do is I want to use this to basically delete some amount of mesh. Okay, so I'm going to do like a Control-C, Control-V. This is going to be slightly bigger. And I'm going to do a group, or we can do a delete. We can straight up just do a delete. Okay, so let's do a delete here. Okay, sorry, we can't do that. Okay, so let's do a group. And I'm going to do a group and take this. And bounding and points. Okay, sorry, this is points. Yeah, okay. So we're selecting these in the middle, and we'll just call it delete. And then I can take a blast and delete these. Yeah, so we get like this hole in the middle. So what this should help us with is if I move all of this down, and we feed this in here, like if I look at my final result and I feed this in here, see, you'll see that they kind of flow around this thing, which looks a lot more interesting. Like if I if I look at the whole thing from a distance, see, so you'll get like, see, wherever these holes are or wherever the spheres are, it kind of tends to flow around that. And then you can, like, as I said, like if you feel like it should be more dense, we can just, you know, go higher. So let's do 0.04. See, there you go. Okay. So you can see like everything, everywhere there's a sphere, it tends to sort of, you know, just flow around this thing. Okay, another thing I think what we should do, and let's see if this works or not, is again, like some of these points are not really sort of matching because it's trying to find a bounding box, right? So the center isn't exactly on the plane. Let's see if array sop works with this as well, because this is a primitive, right? So it shouldn't be a problem. So I'm just going to take, you know, this and that just for testing, and let me just see this. And if I take this and I do minimum distance, yeah, there we go, perfect. Okay, so this works, which is good. And we're going to do the same thing here. So there you go. See, so now it is lying on the surface, which is basically what we want. Okay, so this is all perfect. You know, this is exactly what we want. So the idea is just gives you something a little more interesting, you know, whenever I make a change, it'll look a little more, you know, it looks a little more organic. If you want, you can try to give it a smooth as well, you know, so that looks a little bit better, but I think this looks nice. Okay, we'll do a smooth thing later. All right, so this is where we are, right, after putting in the spheres and everything. So the only thing I want to do after this is I want to generate, like instead of a sphere, I want to have like a spike in the middle. Okay, so something a little more fancy. So in the next lesson, we'll take a look at, you know, how to generate or how to build a spike, and then, you know, replace the sphere with that particular spike. Okay, so that's what we'll take a look at in the next lesson.